We've been having a whole bunch of conversations about what is it that Graphian's doing. So now we're on the same space of, all right, we're taking state out, we're taking lessons from MPLS, SDWAN, so on. The real problem that we really want to tackle about what our control plane is meant to resolve is this piece. How do you make the encryption problem go away from the data plane? Because we know we have to set up the end-to-end encrypted pathway. The relationship, the security associations have to be edge to edge. There can be no decryption in transit. Every other solution that currently exists, because they haven't decoupled those, they typically will have those tightly coupled. Your data plane and your encrypt-decrypt boundaries are usually tightly coupled, whether it's WireGuard, IPsec, TLS, whatever you're using. How do you make that different? For us, we need to think about, we're entering a world where I have a whole bunch of regulations around what kind of ciphers I can use, what certificates I can use, where I can store those certificates, and what is the lifetime on those certificates, and where the private key and public key will be, which key pair you use for all these kinds of different things. So how do I tackle a solution, build it in a way that right from the get-go, I will be compliant, meet every regulation, NIST 800, FIPS 140-3, whatever it is, that I'm good for it. This is where, for us, it was, there can be no pre-shared keys. There can be no key saving or anything of the sort in any shape or form. Even when we think about it in software terms, the software, even if you shouldn't generate keys and put them in user space. That shouldn't be happening. There shouldn't be any passwords saved in shadow files or anything of the sort in this service. So when we look at hardware and software, what are we doing? From a hardware standpoint, we always ensure we use HSMs or TPMs, and which is why the kind of devices that are certified to become part of this service have to have an HSM. We don't generate the keys, we leverage the HSM to actually use the private public key pair on the HSM, and then use those to set up the necessary primers and symmetric encryption keys after the fact. So the key store is always on device in the HSM. Even in the virtualized space, we've entered a world with, whether it's KVM or even ESXi 6.5 and onwards, with AWS using Nitro TPM, with Azure using confidential computing. There are now tamper-proof modules and HSMs for virtualized infrastructure as well. So we are one of the entities from a service standpoint, all our virtual machines as well, and even the services that we provide in AWS or Azure, they actually use key stores in confidential computing and secure enclave. So there's no key generation, even in the VM when you deploy an AMI. When we started our, building out our service, we actually worked with Microsoft Azure's confidential computing group, as well as AWS's Nitro TPM project, to make sure that if you see our instance on the marketplace and stuff, it actually always will use the tamper-proof key stores for even our virtual machines. Because we know that living this with the SD-WAN world and even before, the key store became a problem. And for us, it's also important that data sovereignty and data control is very essential. We cannot have the keys to your data. The keys must be in a key store that the user controls. So whether it's the box, it's on that module. If it's a software package, it's in a virtual software key store, but tied to an HSM. We do not have pre-shared keys or store keys. Using this, then it becomes the case, well, what's going to guarantee the unique identity of the device? This is where, leveraging the key store, we ensure we're able to deliver certificates to the edge endpoints so that they have certificate-based identity around identifying them into our service. Now, this is where, again, certificate rules have become more and more strict around what is the lifetime on a certificate and how quickly you're supposed to rotate certificates. This is where the lesson for us was, we now need to have a multitude of certificates with different lifespans, some that rotate very aggressively and some that rotate a little bit slower. some that you use for day-to-day operations, and some that are there for in case of emergency, because we've all had an event where someone renewed a cert, didn't do it properly, and caused a whole outage. So this is where layering multiple levels of certificates into the solution is built by default. Now, what certificate authorities can you use? Again, because Graphiant provides this as a service, you're able to leverage DigiCert, you're able to leverage a bunch of other services. If you want to use Let's Encrypt, those options are there too. And if you want to use private, CAs to issue those certificates, that also is possible. But again, our solution makes sure that because the key store is there, we issue a multitude of certs. Some with short lifespan, like maybe a couple of weeks, some with 6 months, some with a year. But you'll see that nothing is really going to exceed that because the cert rules don't really allow for that, especially if it's going to be over the public network. With the certificates exchanged and issued to the device based on the keys that are in the key store, the edge then establishes the connection to this cloud portal by which you can now manage everything. Now, this is where you know that this is happening in the background, and should you want to make changes to it, you can, but this is all delivered as part of the service. You're not having to do all of this, but we're making sure that as part of the service, you know that there are no pre-saved passwords anywhere in this environment. You'll have your own username password to access the portal, but the actual edges and every component inside does not have any pre-shared password. Once the control relationship is established, then the edge device doesn't really need to reestablish all kinds of different exchanges with the core network, because then it's relying on the metadata information that the control infrastructure from our cloud delivers to the edge to say, these are the metadata information that you need to use when communicating with the core. So what is the key exchange mechanism? How does the key magically appear on the other side? What is the mechanism by which we do that? For us, the idea here was the key cannot be moved in transit, right? We cannot, and this is where from a language standpoint, what is the relationship that we need to do? This is where we leverage the public key information that is on the HSM on the edges to generate the necessary Diffie-Hellman primers to exchange between the edges so they can establish the security association edge to edge. This security association is being established independent of what would be a classical tunnel. So the edge to edge relationship is not a tunnel that is going edge to edge. This is purely a security association that allows for the encryption and decryption of data between those two endpoints. This is where we've separated what would classically be the relationship, the tight coupling of the actual tunnel with the keys themselves. So what that allows us to do is that the data will be encrypted edge to edge, but there is no tunnel that runs edge to edge. There is no reason to build a full session state and run BFD and run IPSLA and run anything else. But the payload is encrypted edge to edge, and only the edges can encrypt and decrypt that payload.
So how does the time to do this on each edge compare with a typical IPsec operation?
So here, when we think about, if I use a classical IPsec relationship, I mean, we're looking at even finely tuned, let's say 7 seconds to 12 seconds for the full handshake. Then you have the IPsec setup. If you go to the SD-WAN model, it was a little bit better, where you could establish the initial control exchange within, say, 7 to 14 seconds. The IPsec took a couple of seconds, but the problem there would end up being, as you would go into a meshed environment, your N or N squared problems start to explode. So in those sessions and anytime that flap happened, that became a problem. Here, the advantage is it's not an end-to-end IPsec tunnel. So you'd never hit the N or N squared problem ever. Your edge is only ever establishing, from a data plane standpoint, a connection to the core. The security association key exchange now doesn't need a full session state handshake. So we're only looking at a few seconds at the most, depending on the latency between these 2 points and the cloud that it's communicating with, around the Diffie-Hellman primers that need to be exchanged.
Okay.
So I would say in testing, this is a few seconds. In like bad cases with high amounts of latency, it's a few seconds, because now I'm not looking for 5, 6 keep alives to measure if this is up or not. It's just a security association key rotation event. So if we really wanted to, we're not at that point yet, but if we wanted to do aggressive key rotations, so you have your symmetric keys changing, let's say, theoretically every 60 seconds, which would be incredibly aggressive, it would be possible because there isn't the relationship with the tunnel in this situation. So you could rotate these keys incredibly quickly.
Yeah, and that was going to be my follow-up, is that's the first establishment. So how long do you then keep the keys and use them before I throw them away for space, et cetera, after the first?
Our rotational model right now, I think as we're testing, we'll look at like 12 hours, 24 hours to do that kind of testing. I know I have some customers who are immediately going to be like, well, I'd like it down to a couple of minutes. We haven't hit those pilots yet, but architecturally, you can configure it down to like 60 seconds if you wanted to. Typically, no one has asked us yet of that. A day gets us the checkbox.
Yeah, I mean, it's clearly much better than the current solution, or appears to be.
And this was where it was, especially when we think about, when we talk to networking people, it's like, well, the tunnel is the tunnel. I have to build this tunnel. It's like, well, if the encryption is separate from the tunnel, what do you mean the encryption is separate from the tunnel? Is it transport mode or is it tunnel mode? But what is this? So from a header standpoint, we'll look at how the ESP header comes in, how the integrity protection header comes in, but the key rotation is decoupled from the tunnel. The tunnel has no association to the actual encrypt decrypt keys, because if you think about what is happening from a traffic standpoint, when the edge has to send the traffic, it's using the security association of the final destination, but its next hop is the core. And the next hop doesn't have a key pair association. So there's no encrypt decrypt event associated to the route next hop. And when the next hop hits the core isn't even doing a route lookup, it's looking at a label. And so it label switches the packet all the way to the final destination. And the final destination is when you get the payload. It's like, now I have the security association for this inbound traffic based on the label that I've seen.
Right, but it's not really the final destination, because it's really the edge of your network. So this is almost like we're doing an SSL connection between two routers instead of between an endpoint and the server.
Yes.
And
oh, my question.
That's exactly what I was saying. It smells more like SSL with keys than it does
I would agree.
And then MPLS throw on top of it.
I would agree. Yeah.
Right, but
Or
it's
SSL at layer
collapsed
3
the
instead of
domain
SSL
of
at
the
layer 4.
encryption, which also means there could be encryption inside this encryption, depending on the app that's running on top of it, which is your next slide. I'm in the ringer.
And so that is precisely right, because now you have because you're not tied to the tunnel, now you can layer on the encryption levels that you want, and goes down to segment, to application. You have a lot more flexibility on where you apply the encryption space. Now, there is a certain agency in this country that runs several sub-networks within their network and several encryption levels of standards within those networks. The possibilities there become a lot more interesting. And this was a very painful project. We just ran get VPN over get VPN over get VPN in the current deployment model that was approved, 9 years ago. So that was the standard that got deployed. The performance is terrible in that environment for obvious reasons. But we saw that challenge, and especially when you think of truly multi-tenant networks that have very high compliance requirements, just layering on IPsec definitely doesn't work. But there isn't really an SSL answer either, because not every application is TLS. And so what do you do for a huge amount of infrastructure that needs that kind of compliance, don't want to kill your performance with overhead, but don't have the ability to entirely upgrade the application to TLS and get that encrypted end to end?
Right. Yeah, I'm thinking in healthcare, there's a lot of those old applications out here, and to have this confidence that that medical diagnostic imagery and things are
Exactly.
completely safe in transit is a.
And now when we start thinking about especially genomic data and the kind of personalized medicine and CRISPR and gene editing that's happening, the level of scrutiny on, because now that data identifies you and every single possible pharmaceutical drug that can be made for your specific gene map. Now the level of compliance is getting even more serious about that kind of data and how do you protect it.
Yeah, but at the same time, I really want the best expert in the world in Britain to be looking at my images.
Exactly, exactly. And right now, if you were to, I mean, I think we know for a fact, like typically, oh, are you going to plug it into a USB and mail it to someone? And I kid you not, there was a medical company that told us that that is how they were transporting data. They were putting it on USBs and mailing it via FedEx to each other.
I'm surprised it's USB. Most of them are still using DVD.
Oh my God.
Seriously.
Yeah,
As a patient, I got handed a DVD burned copy of my images the last time I had a CAT scan done.
Oh, wow.
So.
And this was, I think, we would see, even when we do like the SD-WAN projects, one of the biggest hurdles was in healthcare, because even if you got a healthcare partner, the hospital really didn't want to change because it would mean overhauling so many things and their compliance officer wouldn't sign off.
Well, it's not allowed. I mean, the real problem is not the healthcare institutions, it's the approval of the devices. You can't even patch the damn thing.
That's true.
Because they are approved at a specific reversion and patch level. So you're not allowed to by regulation in the United States. It's craziness.
And it was like during our last couple of years, there was a medical manufacturer. They were trying to submit the paperwork to basically deliver a business model where they could turn their devices as a service. Mm-hmm. So like, you know, microscopes and scanners and stuff, and provide those to the hospitals as a service. But not only could they not really get through all of that regulatory hurdle, but it was also the infrastructure, just a capital expenditure to make that service possible was north of $50 million. And just the idea of how many VPNs would you layer on to make that possible, that project got, I don't know if it's been shelved or just abandoned, but it didn't end up actually happening.
Yeah, it's a security nightmare in a hospital because, you know, you got Windows 95 or even older systems running there, and you have to segment them off and protect them because they have to run, but they have to be networked.
Yeah.
We actually have a question from Twitter, which you've answered, but I want to make sure that it gets answered. Can customers choose their own CA?
Yes.
And you said yes. And then did you say you can also do like self-signed?
So
internal CAs.
You do an internal CA.
Yes. So self-signed is we
never mind.
Yes.
Internal CA is good enough.
This is where we also saw, and this would come up in particular with federal space, military, and the big banks. I think there was almost nobody else who asked for like their own CAs, even during the SD-WAN projects, like 2013 onwards. There's always the big banks, we know who they are, the big four, not even like mid-range, just those, government, military. Everybody else, I think based on people's experiences with DigiCert, Symantec, Google, Let's Encrypt Everything, a lot of that had shifted. The question that we started to get more was, can you have multiple? Can I have multiple root chains and multiple certs, especially after some of the kind of situations that happened in the last several years, where someone's chain got compromised?
Right,
having to redundancy of certs became the bigger question.
Is that like a failover the cert type thing, or is that a
No.
endpoint A is using this chain and endpoint B is using a different?
It's multi-factor, right? So you have to use multiple certificates to authenticate.
Even better.
The multiple certificates from multiple PKIs.
Sorry?
Is that for
Yes, multiple PKIs.
Okay.
So different CAs. All right, so if we're able to do this, this is where what the consequence of the state machine becomes in our environment. So what is the state and where is the state? Because we've talked a lot about encryption, tunnels, routes, VRFs, where is it all residing? And this is where you'll see, right? Typically we know in like the actual LAN space, most of the hosts, there's no IP or Linux networking or route tables inside the hosts running a routing protocol. Typically just default route. The edges are where we collapsed as much of the state as possible so that we create a distributed state machine distributed across all the edges rather than in the core. If you contrast this with any other environment right now, the majority of the state is in that core. And this is true for architectures. Anywhere you see someone trying to put in or say that they're providing the firewall in transit, that means that is happening. The state is in their transit because they have to. They have to decrypt, they have to have the VRF, they have to have the route table, they have to point to one interface on the firewall, take it out of the other interface on the firewall, bring it back into the VRF, reroute, re-encrypt, and send it on its way. And this is true for anyone that has to do it in transit because there's no other way to do it. This really matters to us because this will raise the question again, right? We aren't a SASE. What we are trying to do is get you to the security solution of your choice so that the decryption event happens there, but not all the way through. So for us, the goal isn't to try and put all the security services in this transit. Our goal is to get you to Zscaler or Sky High or Prisma or Umbrella or whatever. We don't care about that part. Our part is if you load up the middle, the performance will be affected. And just talking about that healthcare piece, from a regulatory standpoint, we do not want to have customer data exposed in our infrastructure. We do not want that regulatory overhead. So we can guarantee that at no point can we ever see anyone's data. We don't have the key. It can never be opened in our environment. Even if someone were to, let's say, hack into our infrastructure, they won't even see customer IP information. There's no routes, VRFs, tunnels, nothing. The worst they could do is cause an outage. And because there isn't a whole-scale BGP setup that is routing and advertising all the prefixes, if an outage happens in my core, because of the way the convergence happens, your edges move over to other cores very quickly because there's no full BGP route reconvergence event happening inside the core. So for us, the biggest contrast is when you, I know the Kentic folks are here as well. I love their solution and the Thousand Eyes stuff as well. You would use that to see what's happening on the internet, but you're gonna do anything to the ISP network. If a route reconvergence event is happening, it's happening. You just have to wait. Rogers knocks out all of Canada, and you're right? What do you do? So this was where the whole premise was, if the core is stateless, then you aren't susceptible to those kinds of route reconvergence events. And maybe the consumer space is not really going to be benefiting from it as quickly because we're going to charge a premium. But the enterprise space will totally see the benefit of, yeah, I'm not subject to that kind of IP transit route reconvergence. If I describe that situation for us in that scenario, because we're peered on the Rogers last mile, you could use the last mile to enter our core, but now you're no longer bound by their BGP peering with anybody else. You're inside the stateless core. You are no longer susceptible to the ISP BGP events happening inside their internet network. You're now riding this private infrastructure with the SLA that you're supposed to get as part of the service.
So how exactly do you, you've been talking about all the specialty connections up to this point, but
yes,
obviously the general internet is needed at these edge sites too.
Yes.
So what are you doing with that traffic when it comes into the edge and it's just the normal internet, not my wonderful special applications? And
so this is where, from a last mile standpoint, from the edge as it hits the core, this, I believe, is the question of what does the header look like? And we're going to go into what is the header look like?
I'll be here all week.
The biggest piece, and one of the things we realized was, we know like we've been talking about V6, I think, since before I was in networking.
Yeah, we'll eventually deploy that when we get around to it.
Exactly. the challenge that I also realized during the SD-WAN stages was no one really had an easy way to get you even a piece of v6 into your infrastructure. Like it would mean having to redo a whole bunch of your stuff. And we all know there's no graceful way to go from v4 to v6. NAT is not an answer. What do you do? How do you even bring in a piece of v6 in some shape or form that isn't massively disruptive? And for us, it became the question of, can we use v6 to get the extendability that v6 has and make it easy for the customer to, in a way, say, yeah, on the WAN side, you already kind of use v6. If you use the Graphiant service, you didn't even have to do anything. You're kind of using v6. Could we do that? That would at least ease the world into some kind of adoption of v6 as opposed to where we're currently at.